Okay, so we just spoke about quantitative data in which we were using t-tests. Now, supposing we had tables, we wanted to see whether there were qualitative data. Instead of age, we wanted to see another variable which was also classified as 0 and 1. And we want to see if this was different between the men and the women, which is also classified as 0 and 1. So we have two variables which are both qualitative, and we want to see if there is any test of association of qualitative data. The categorical data may be summarized as frequencies, like we have already done now. We were talking about this. Now we are trying to determine whether there is relationship between two variables which are both qualitative, both have 0 and 1 values, and we are looking at it by what we call contingency tables. Again, another way to kind of confuse you. Any table which gives you a relationship between two variables is a contingency table. So any table is a contingency table. So by putting it into a table, we see if there is any association between any two variables. That's the problem that we are trying to figure out. Let's say we are trying to figure out if there is an association between the sex of the individual and the length of the hair, which we have classified as long and short. So if that was our question, then which test of association we would be using? And the test is, so let's before I tell you the test, let's see what are the steps in determining this. I just want you to get an intuitive idea of what's happening. I will not doing it. I will not teach you the statistics or the formulae for doing it, but only the steps. So in one, we have got the observed frequencies. We know how many men had long hair. We know how many men had short hair. We know how many women had long hair. And we know how many women had short hair. So that is the table of observed frequencies. Please remember and mark this word. We have observed frequencies, what we actually saw in the data. Then what we do is we make a table of expected frequencies, assuming that there is no difference between men and women and in the length of their hair, and there is actually no association. If there was no association and everything was happening by chance, we try and think what would be the expected frequency of chance. And then we determine if there is a lot of difference between the observed and the expected values. And then we try and quantify this by means of a p-value using what we call a chi-square test. And when we are trying to see if the observed value is very different from the expected value, then we get what we call is the chi-square test. And when we apply this, we get, it tells us whether there is an association or whether there is no association. But it does not give us any indication of the strength of association. And again, if I try and show you on the demo, and let's see what happens. Again, it's not very difficult. Let's see, I want to see the statistics, summary tables. I want to see, so the easy way to do it is, let me do religion. Is there any difference between the religion of the individual and the sex of the individual? So I just give a command that tabulate sex and religion and give me the chi-square test. That's a simple command, tab sex religion comma chi-square. And no, it did not find the variable religion. So let's see what religion is named. So it's whether the person was Hindu or not. Let's do it that way. So it's tab sex Hindu chi. So it will give me a table. It has given me that the men, there were 36 Hindus, and women, there were 2 Muslims and 32 Hindus based on the labels that I have given to 0 and 1. But it gives me that the p-value is 0.1. That means the difference between being a Hindu or being a male and female, it does not matter whether you are male or female. In this data, it does not matter. That's how the chi-square output looks like. And what you need to report is only the p-value, that whether it was significant or it was not significant. That was just for demonstration, that is how we kind of demonstrate on this. With that, I come to an end of most of my presentation. In the last 3 slides, which I have put up, are choosing an appropriate test. Let me summarize this. And again, if you miss this out on this, probably this will help you if they are sharing a recording with you later. So you need to see whether it's an observation or experimental study. This is just about study designs. It could be an observational study or an experimental or an interventional study, 2 kinds of designs. The interventional study depends whether the allocation is a random or not random. So if it is random, then it is called a randomized trial. If it is not random, it's called a non-randomized trial. Forget experimental studies, there is nothing more to it. If it's an observational study, no intervention is being done. Is there a comparison group? Yes or no. If there is a comparison group, then it is called an analytical study. If there is no group to compare and there is only one group, then it's called a descriptive study. Beyond this, if it's a descriptive study, it's largely a survey. And if it's an analytical study, you need to see what kind of a comparison group it is. Is it disease versus non-disease? Or is it risk factor versus non-risk factor? So if it's a risk factor versus a non-risk factor, and then the disease develops, then it is a cohort study. I know it's not going to be very easy to pick it up in the last few minutes of a long 2-hour biostatistics class, but maybe when you sit down and look at it, it might become a little easier. If the allocation is based on the disease, whether it was disease versus non-disease, then it becomes a case control study, and you're trying to figure out कि diseased में exposure कितना था and non-diseased में exposure कितना था, then it becomes a case control study. And if both of them have happened already, disease and exposure, and you are studying them at the same time, then it becomes a cross-sectional study. That's as much for the study designs. Now coming to types of variables, same slide that we saw at the beginning of this. Remember this, 4 kinds of variables: discrete, continuous, ordinal, and nominal variables. Now, if we go further from here, this will determine and tell us how do we determine which statistical test to use. In the last 2 minutes, we'll go through this algorithm, which will determine which type of statistical test we should apply in which situation. So again, I need your 100% attention for the next 120 seconds, in which we will figure out what test to use in which type of study and which type of data. So if the type of data is quantitative or categorical, obviously there are only 2 kinds of data. Then if it is a quantitative data, is it continuous or is it discrete? If it's continuous, it's represented by the mean. And if it is discrete data, then it is represented by the median. So remember this, if it's continuous data, mean; discrete data, median. How is it distributed if it's continuous data? Is it normal? Is it not normal? Now, if it is normal and you need to determine whether the comparison is paired or it is not paired. And if you remember, again, even if it is normal, we need to see if it is paired or it is not paired. The test to apply, if it was paired data, then we use a paired t-test. If it is not paired, we use an unpaired t-test. If the data was not normal and it was paired, then we use a Wilcoxon sign rank test. And if it is not paired and similar to an unpaired t-test, then we use what was the Mann-Whitney U test, also called the Wilcoxon rank sum test. So don't get confused between the two of them. Again, it's a play of names, and there is no other way but to remember it. So that's only for the continuous data. Let's move on to the next, which is the discrete. We leave out here. If the number of groups was more than 3, then we use the ANOVA. And again, if it's not paired and it's not normal, then and the number of groups is more than 3, we use a Kruskal-Wallis test. Supposing we have a discrete data which is not continuous, and we have paired again or non-paired. If it's paired, we use the Wilcoxon sign rank test. If it is not paired, the Mann-Whitney U test, something similar like this. Looking at categorical data, whether it is normal or not normal. If it's normal, we use the chi-square test. And if it's not normal, what we use is the Fisher exact test. That is how we identify which statistical test to use. And we already did this, which study design we need to use. And that's the end of my presentation. And I thank you for your patient attention.